Nothing. Doing my physics lab, and as usual, I never understand anything.
What don't you understand? What are you doing? Electrostatics? That's easy. Here, I'll explain this entire thing to you.
What do you mean? You know how to do this?
Yeah?
Oh my god, you're a
Electrostatics.
lightsaber.
Let's go.
Okay.
Okay, so we've got our foil leaf electroscope. As you can see, we've got the copper wire running through the mason jar with the two metal leaves at the bottom.
Oh my god, these are actual.
Okay.
So this is the electroscope. How it works is if we charge it, because the fact that same charges repel each other, the leaves in the electroscope will separate. The amount of distance between the leaves actually depends on the amount of charge the electroscope has.
So basically, using fur and a plastic rod, I'm going to charge the rod, which is currently neutral, as well as our electroscope. And I'm going to charge the plastic rod negatively with the fur by rubbing it.
So you mean all the negative charge from the fur are moving onto the stick?
Exactly.
Oh.
And now, since my object is now negatively charged, and if I bring it and touch the electroscope,
That's like magic.
the leaves separate.
So wait, what actually happened? Because I know it's not magic.
Obviously not. It's electrostatics, Bella. So basically, the electrons from the rod, when I touched the copper wire, were transferred and went into the leaves, which is why they spread apart.
So that was
because
the
they're
reason
both
for separating the leaves.
Exactly. They're both negatively charged, and two negative electrons want to get as far away from each other.
So like you mean two electrons, which are like negatively charged, obviously, they want to repel. So that's the reason why the leaves are moving really far apart.
Exactly.
Ah,
Do you get
I
it?
see. Oh my god.
Here, I'm going to
high
try
five.
for the next one. So this time, I want you to charge your rod, and instead of touching the copper wire like I did previously, just bring your charged rod near the wire. Don't without touching, and observe what happens.
It's already starting to repel.
You see?
Yes, because all the little negative electrons are moving from the rod into the copper wire and are causing the leaves to repel. Is that right?
Exactly. Perfect. You don't even need to touch it. It's being charged by induction, basically.
Ah.
All right, so moving on to experiment number 2.
So what's gonna happen?
Okay, so we've got our pieces of paper, our fur, and our rod. Now, our rod is not charged, correct?
Right. So basically, when you're gonna bring it close to the paper, nothing's gonna happen.
Exactly. See? Nothing, because it's neutral, it's not charged. But now, I'm going to charge my rod, and when I bring it to the paper...
So all the positive and the negative charges come.
Exactly!
Oh my
Would you
god!
look at that? They're like sticking.
They're actually sticking.
It's the same concept when you have a balloon and you rub it on your hair, and then your hair sticks to the balloon, or it like sticks out.
Oh, or even like with a comb. Like sometimes when you're combing your hair and you have like little papers. Like, oh, I get it. Okay.
So if we take the example of when you comb your hair, the comb pulls some electrons away from the protons in your hair, and then this comb gains the extra electrons that are now static, which means they're staying in one place. We call this static electricity, and the reason your hair will stick to the comb is because of the extra electrons pulling on the protons.
So what about the two charged pinballs? Do they work the same way?
Yeah, basically. Here, you can try and explain to me what's going to happen. Oh, wait. Works better if I charge your rod.
That's true. So the two pinballs have the same charge, so that's why they're repelling, right?
Exactly.
And that's really cool, actually. It's like magic.
They're dancing.
Okay, and if they come close to each other, oh look, they still have it. So I guess you're gonna make them neutral. Now,
And if one of them had an opposite charge compared to one, like if one was positive and one was negative,
they're
what do you
gonna
think
be
would happen?
attracting each other, right?
Exactly.
They're gonna come closer. Oh, that's really cool.
See, physics is easy.
Yeah, I think I got it now.
On to the next.
The two lightweight pith balls suspended from the strings are attracted to objects with a static electric charge. The pith balls can also be charged by touching them to an object with a charge. So, what is the Van der Graaf? It's basically a device which creates a high electric potential. It was invented by Robert J. Van der Graaf, and it can produce on the order of 100,000 volts and can store enough energy to produce a visible spark. Here are some demos. So, what's happening here? The Van der Graaf generator basically works by static electricity, like when you shuffle your feet across the carpet and shock yourself on the doorknob. So what happens is, big rubber bands move over a piece of felt and strip away the felt's electrons. These electrons move up the rubber band to the metal ball and then into the person. The electrons repel each other, so they try to get as far away from each other as possible. So we see this effect with the hair standing up in the experiment. Generator, all that electricity will go through your body, giving you a big shock. It can actually be really dangerous. You can be protected from the ground by standing on a piece of plastic, which is what I was doing in the experiment. We say that plastic or rubbers are insulators since charges can't travel through them very easily. Strangely enough, our insulator didn't work so well because I got a great big shock during the experiment.
Just because it's harder.
It's ringing!
So, what we just saw with the pie plates and the Rice Krispies is that the objects become charged due to the Van der Graaf, and since like charges repel, it explains why the pie plates and the Rice Krispies go flying. So, we hope that you now have a better understanding on how electrostatics works, and that you can now finish your lab with a breeze. If Bella can do it, so can you. Thanks for watching.
Act 1, take 2. Action.
Stop. Students.
Cut.
I don't understand. Oh. Where did she go?
Where did she go? Hey Bella, what do you got?
So all the sorry. Okay, so wait, all the negative.
What are you doing? 3, 2, 1, action.
Obviously.
Oh my god.
Really? Ow! Ew, I can feel it around my mouth.